Good morning, everyone. Thanks for coming. Thanks for coming to tent. Kind of weird, but whatever. Today, topic of this session is Project Astoria. Astoria started about a year ago or so as an exploration effort to sort of try to see how we from the Microsoft data development team, how could we help sort of this new set of needs around exchanging rich data across the web, across services, across clients, across separate applications, and so on. Since that initial effort, we got very good feedback about it. So since then, we've been working on productizing the system and turning it into a full-on part of the Microsoft development platform offering. And so I'm really excited to come here today and talk about what Astoria looks like at this point after some time of transitioning from an incubation effort to a full-on effort as part of the Microsoft development story in general. My name is Pablo Castro. I am a technical lead in the data development platform team at Microsoft, and I lead the Astoria effort. And so how many of you actually have heard about Astoria before? Wow, that's quite a few. So that's actually great. So the plan for today looks more or less like this. So I'll make a few assumptions as little as possible. If I don't talk about something that you think is important to understand the rest of the session, feel free to jump in, stop me, and I'll be happy to clarify it. The plan is I'll spend a few minutes sort of doing, you can call it a problem statement. Sort of what problem we're trying to solve, what do we think the state of things are right now. Then I'll spend some time defining what a data service is and what it looks like. Then I'll sort of drill down in detail into how to create data services, how to consume them, configure them, and so on. And finally, I'll sort of spend a little bit of time at the end trying to describe sort of how the various pieces fit into a bigger picture that we are optimistic about getting to in some time from now. So let's get started. About data on the web. If you look at a traditional web application that you will build sort of any day today, the way typical applications look like is, say you're using ASP.NET. So the general interaction model is you get an HTTP request on the server, you catch it in your page does a bunch of queries. I'm assuming this is a data-driven application. So you do some queries against the database, get some results, render some HTML, and ship it down to the client. So by the time it makes it to the client, it's HTML that has formatting and data and all of these constructs mixed up. And it is actually a fine development model. It worked for a number of years, and it continues to work great. However, there is a set of technologies that are emerging these days that are changing some of the needs around how data is used around web applications and how it is shared around web services. First example is Ajax applications. If you look at what an Ajax application looks like, the key difference is that when you hit a web page, what you get back is an HTML page and maybe some JavaScript files and some pictures. And in general, it constitutes presentation information and client-side behaviors, like code to manipulate the UI and stuff like that. But it doesn't have the data most of the time. The first thing that page does is goes back to the server and pulls data and renders something in the UI. The point of that is to create more interactive applications. By doing that, you can then stay in the page, and as you interact with your browser, with your web application, the page can, under the covers, go back and forth between the client and the server and exchange peer data while the UI stays on the client and stays responsive for the user. Now, that already changes the way data is used in this, in applications that are web-facing, because now instead of having a server-side component that connects to the database, pulls some data, renders, and sends to the client, what you have is a component that sends basically files to the client, and then you have to build infrastructure to go talk back to the server and get pure data in somehow. You can use some XML format that you come up with. You can use a well-known format. Maybe you use JSON or JavaScript object notation, which is sort of a fashionable thing to do these days. So it changes the way data is used in general in your application. A second scenario is Silverlight. If you haven't heard about Silverlight is a technology coming from Microsoft where what we're trying to do is enable the creation of more interactive applications by allowing you to use our existing toolings, Visual Studio, our programming languages, our libraries, and so on, to create applications that run right inside the browser and follow the browser to the friction-free deployment model. Same problem. In this case, Silverlight, or even you can go outside of Microsoft offerings and look at Flash-based applications. Same problem happens there. When you connect to those web servers, what you get back is like a Flash application or a Silverlight application, and there is no data there because the application has been compiled. So the first thing you have to do is you go back to the server and retrieve some data, and as you interact with the user, data goes back and forth between client and server. Another thing that happened is services have become sort of a very common thing out there on the web. Some of them look very clearly like a service. Others have evolved from being some website to being a huge service that has their own UI, but also they become a platform for others to build applications and services on. This can range from Flickr to Amazon to Live to all of these big organizations that sort of have grown sort of what was web applications into full-blown services available out there on the web. Again, when you're interacting with a service, what you interact for the most part is in terms of data, because the interface is typically your own interface. And finally, there is this mashups thing. So mashups are interesting, among other things, for a particular fact. They are interesting today because of the amount of data that is out there. It's not like the actual technology for mashups wasn't there before. I mean, in essence, it's a matter of sort of going to this number of websites and gathering some data and presenting it together in a consolidated user interface. The key aspect, or at least in my opinion, why mashups are so popular now is because now there's so much data out there to build like amazing things just by stitching bits and pieces of data together from different sources. So all of this picture, basically what it's trying to paint is a strong trend towards a separation between what is the UI services and the presentation services in general and the data services. Data is becoming something that is required by all of these various scenarios, and is completely independent from the presentation infrastructure. Of course, you want them to work together, but in principle, there is a lot of infrastructure that has been built already for delivery of presentation and creation of presentation components on the client, and it hasn't been the case for data. In the case of data, we have focused for a number of years on the middle tier and how middle tiers and web servers talk to the database, the next tier down, but we haven't focused so much on data services in the next tier down between the web server and the consumer of those web services, which could be a web client or another web service or something. So this is the space that we think there is we can help make creating these services and creating this class of applications easier than it is today, and it's the problem that Project Astoria is trying to solve. So how do we solve it? Wrong way. So there are a couple of aspects about creating a data service. If you look at the options today, you can say, well, in the end, what I need is, let's say I have some JavaScript that runs on the client, and I want some data from the server. So you can roll a quick sort of handler on the server or script that hits the database, pulls some data, renders it in some XML format, and ships it to the client. And it's an invented format with an invented mechanism to say what you want, and an invented mechanism to say what you want back. The problem with that is, if you want to create services so that all of your services look the same and they are uniform in the way you interact with the service, you need at least a set of patterns that allows you to make assumptions about what the service look like. You need to know how the URLs will look like and how the data is going to be exchanged between the client and the server. So what we try to do is we picked a set of sort of guiding principles, if you will, that shape the way services are exposed in Astoria. So first thing we did is we said, look, the goal here is to enable applications to consume data. Web applications are so diverse and they have so different requirements and run in so many different places that we can make very few assumptions about what is available. So first thing we did is we're going to use a REST-style interface. REST stands for Representational State Transfer, and there is a dissertation that Roy Fielding wrote some time ago that is sort of is an interesting read if you're interested in the space. But in essence, it captures a class of applications or an architectural style that results in applications that are very simple in principle, have very crisp, very well-defined interaction models, and scale at very large scales. And like the commonly cited example of a REST application is the web itself, and how it has scaled so far. So what we did is the following. We said, OK, we want to present this interface as an HTTP type of interface to browsers, because that's what is everywhere. We don't want to invent something new, because otherwise, probably it's not going to be sort of broadly available. But we have to define a model for the data that sits underneath the service. So we picked up a model that was already supported by other sort of other infrastructure components and tools and runtimes in our technology stack, called the entity data model. There is a bunch of philosophy about the entity data model, and we have some documents to describe it. But the short story about it is a conceptual level modeling language, and it defines two key concepts. It defines what an entity is and what an association is. So when you model your data, your business objects, you represent your objects as entities, and the links between those objects, you represent them as associations. Turns out that this maps really well to the web, because in the web, when you use protocols like HTTP, what you have is you have resources, and in order to relate resources to each other, you typically use links, you use URLs. So what we do is we use the EDM as the basis for our model, and then we turn entities into resources and associations into links. And I'll get into a more concrete example in a second. Then you have to, once you turned everything into resources, you have to find a way of pointing at stuff. Like, how do you identify a particular resource so that you can tell the system, for example, to retrieve it or to update it or something? So we do that with URIs. Like, nice thing about URIs is, again, nothing new, nothing invented. We're trying very hard not to do that. So it is a standard mechanism. It's supported by all of the libraries out there. It's supported by the infrastructure and so on. And it's a well-defined mechanism to point at things. So we're leveraging that. URIs sort of have a set of rules, but don't define quite the semantics in the path itself. So we leverage that to inject semantics that you can choose to interpret or not. And if you do, then you get some services on top of the basic URI scheme. So once we know how to point to things, we need to know how to exchange resources between a consumer and a producer of a given resource. The way we do that is we use plain HTTP. Nothing fancy, no protocol on top or anything. The nice thing about just doing URIs and just doing HTTP is that if you're looking at a web page, the web page made it to your client over an HTTP request to the server. And maybe there are like firewalls and proxies and authentication things going on. But what you know is that if you made an HTTP request, the page came back. So if you go through the same path to retrieve the data, you're very likely to get it back as well. I mean, it's your best bet, if anything else. So what we do is we expose data over the exact same channel you used to expose the other components, like web pages and so on. This is not only interesting in the one scenario where you have you may have proxies or firewalls so in between the client and the server, but it also, in the broader sense, allows us to leverage all of the infrastructure that is already out there. You can think of things like HTTP caching, already invented, nothing to invent. We can leverage the caching out there. Even geo-caching, like content distribution networks that do caching across the globe, and you get the closest server to your request. Well, you can configure the policies, and if you are just HTTP compliant, you get that for free. Same thing with security, same thing with proxying and routing. So in general, we leverage a lot of the existing infrastructure out there. So next step is we have to give you the data back. I mean, you ask for a resource over HTTP. What do we give you? So again, trying not to invent stuff. Right now, we're looking at supporting 2 formats. We're still arguing whether or not we want more, and I'll take the feedback after the session if you have an opinion. But right now, we're supporting 2 formats. Both are sort of industry standards. One is Atom. To be precise, we're supporting Atom Pub, which is like a syndication format and protocol, which has become an RFC as of like a month ago or so. And we're also supporting a protocol based on JSON. JSON stands for JavaScript Object Notation, and it's very handy when you're working in a JavaScript environment, and you want to be able to make requests to the server and then materialize the request as JavaScript objects. And I'll show a few examples in a second. So finally, the last question is, I've been talking about data and how you share it and how you take it back and so on. So where is the data coming from? We support a couple of options. One is, a lot of times data comes from databases, right? They're already out there. A lot of applications are built around them. There is large amount of information available in databases. So we have a first-class support where you just point us to a database, and then you configure your security policies, and you're off you go. You're ready to go. The other option is, the reality is not all of the data is in databases. There is a lot of data out there that is interesting and is in sort of a very broad set of data sources. So for that, we support a general purpose mechanism to plug data sources into the system. And the way we do that, again, is instead of inventing a new provider model, we are building on top of the language integrated query infrastructure, the LINQ infrastructure, which already defines a mechanism to define queries and push them down to sources. So you can, by doing this, you can leverage LINQ implementations out there, like, there is link to Flickr, link to Amazon, link to Active Directory. Yeah, there is a little bit of everything, and you can use them and still get the same experience. So this was a pass over the key elements. Let me now switch gears and first show you briefly what the service looks like, and then we will elaborate more on what it takes to create one of these services and to consume them. So let me switch to my demo machine. OK, so what I have here is Visual Studio 2008. I couldn't tell you which build is whatever worked last week, but so this is, we're very close to, we're basically done with Visual Studio. So the product is going to be ready very soon. And on top of that, what I have is, I have an intermediate build of the Astoria services and runtime. So I'll talk later on what it takes to build one of these things. For now, let me just execute one, and let's play with the service itself for a few minutes. So in this case, let me show you the data I'm going to be using here. So this is a simple schema, and in this case, I'm using a database as a backend. I'll use something else in a second. And I have customers and sales orders, and then I have products and categories. So let's switch back to the service. And of course, you're not supposed to do that. Like, usually people will not play with your XML. Like, this is more for applications to consume. But this is useful to briefly show what it looks like. So when you hit the root of a service, what you get is a service description. It basically gives you all of the resources and the resource containers in a particular service. Like here, I can see that there's a categories container and a customers container and a products container and so on. And what I can do with this, I can drill down into the container by using the URI space. Like for example here, if I say /customers, what this means is, well, I turned off security in this one service so I could show it. This is like all of the customers in the customers container that actually is coming from the database. So the idea is that whenever you query for something like this, what you obtain back, in this case, I'm getting the atom feed format. And I can see that there is customers. And I can see that customers have an ID and a company name, and they have a phone number. All of this example is around a bikes database. This is like a shop that sends bicycles. So it's like a little company. And this is their customer information. So I can see some properties about it. And also I can see that every resource that is exposed has a unique URI that points to it. So I can copy this URI, put it here. And what it comes back is a particular resource. So this URL points to this customer called a bike store in this particular case. This URL is like when you do something like that in the browser does an HTTP GET to obtain the resource. But this resource is like modulo security policies is fully read-write, meaning if you do HTTP put, which is a standard verb to replace a resource, we will go replace the record in the underlying store, whatever that store is. Similarly, if you do a post against the container, you will create a new resource. And finally, if you do an HTTP delete over one of these of resources, we will just go ahead and delete the resource. Of course, modulo any business logic that may kick in and prevent that from happening. Also, since we have this entity data model underneath the service, we know quite a bit about these resources and what they look like and how they relate to each other. For example, here I have a customer, and the customer has what we call a navigation property. The idea is I know that I have customers and I have orders, and I have told the system that customer is related or associated with orders. And the way I jump from a customer to the order is through this sales order navigation property. So this reflects in the model by, in the payload, what you get is you see a link. And this is, again, standard Atom stuff. Like, we tried hard not to invent something for links as well, where what we're saying is there is a related item. And the URL of the item is this guy here, where it says basically what you have now /sales orders, which is actually the name of the property. So here I can say /sales orders. And what this payload contains is the sales orders for this particular customer. Like here we can say that sales orders has a date, an ID, and it has a date. And if we pick out a particular order, we can keep drilling down. Like I can pick this order and then look at the order lines, that is the actual product items that you have bought in this particular order, and I can see, the quantity and the unit price for that particular order for that product, and even a link to the product that is represented by that particular order line. So basically, what's happening is the system is being driven by the metadata in the entity data model and exposes a resource graph, where each one of the entities becomes a resource, and the various links that you can see, like this one highlighted here, become the sort of the arcs in that graph. So you build a whole resource graph, and it's built automatically for you, just out of the information that was presented to the system. Also, this graph is fully read-write if you sort of enable the security policies to do so. That means not only that you can change the actual entities or resources, but also you can rewire the graph. You can change the links. And I'll get to that in a second. In addition to just being able to browse particular resources, if you're building like a UI application, like an Ajax application, for example, it's very likely that you're going to want to do things like sorting the results and do paging over them and maybe filter them and so on. So the URL syntax has a very small set of options to do some of it. Once you go past certain complexity, we don't want to push it too much on the URL language. So we have a mechanism so you can do full queries or something. But we would like to have a simple way of interacting with services without having to resort to that. So for example, these sales order lines point to products. So let's look at the products container. The products has, well, a bunch of products. And you can, if you look at the product, it has like a name, a list price, and a color. So let's pick on the color. One thing I can say is I can say from the product filter those that are of color red. These 20s, let me just get rid of them for a second. I can say color equals red. We use EQ so we don't have to do weird escaping on the URL instead of the equal symbol. So what this means is go get all of the products that you would have gotten if you say just /products, but then just give me the subset that is actually, in this case, has this predicate is true, like in this case, is color equals red. The important thing about this is something that is not done by the service itself. We take this, we build an iQueryable, like a link query, and push it down to the data source. So if this is a database, then this is executed by the database. If it is, say, linked to Flickr, I don't know, just to pick a random example, then this will be sent to the Flickr service and executed there. Of course, you wouldn't have products, but similarly, you can sort things. So you can say, for example, ampersand order by, and for example, here we could say list price, which would sort the result by unit price. And finally, you can also do paging. For example, I could say, I'm going to page in pages of 2, just to make it short, and I can show you each page. So I could say top 2, which will return the first 2 products. And if I want the second 2, for example, I would say skip to top 2. So that way you can use skip and top to page over the results. And again, you don't have to implement anything on the server for this to work. I mean, the data source needs to support it, of course. But in the case of a link-enabled data source, they typically support that. So this allows you to get data. And so far, we've gotten data using XML and particularly Atom. let's play with other formats for a few minutes. So the browser by default does XML rendering, but not other things. So I have this small helper page that it does the same that the browser would have done. It's just easier for display. So I'm going to point to the same service, bikes.svc, and let's pick something like a simple resource. In this case, the set of product categories. So if I hit go here, this is the set of categories, same format as we saw before. And let's pick a particular one. So I'm going to say bang or like exclamation point 5. And this gives us one particular category, which is the category with a name of mountain bikes. So this is the Atom format. I could switch to the JSON format. And by the way, all this is doing is this changes the HTTP accept header to use application/JSON. So this is using standard HTTP content type negotiation between the client and the server, which is also sort of a well-established mechanism to do this. So this is a JSON representation. If you're not used to it, it's kind of weird. Basically, JSON is a subset of JavaScript that contains no executable forms. It's only basically object initialization syntax, and only in literal forms, no function calls. And it's very commonly used in the browsers because it's very handy for, you can eval this and you get an object. So it's very nice. So this is what you get. So how about modifying this? Let's say you wanted to create a new entry or modify an existing one. How do you do that? Well, you also use HTTP. Like we were playing with products before. So let's say we want to use a product. So here I'm going to say /products, which represents all of the products in my store. So I want to insert a new product. So the way I'm going to do that is I'm going to write the payload, and I'm going to use JSON in this case. Same thing will apply to XML. And well, the product has a name, so I'm going to say name techhead, demo. It has a list price, so I'll say list price something. And it has a color, so let's go with color red. And finally, a product always belongs to a product category. So I have to tell the system that I want to create this product and I want to bind it to an existing category. So just like on the way to the client, we get links, on the way to the server, you also exchange links. That's the way you represent things that are related to each other, which is sort of is a natural thing to do on the web. So I'm going to say category. And then instead of putting a value here, I'm going to use the special token __ metadata. For those of you that are more into data models, you know, XML is great, it has namespaces. JSON, not so great, no namespaces. So you have to do this weird __ metadata thing. And I have one metadata item to put here, which is the URI of my category in this case. Of course, a program will do this for you. Like typically don't write all this. So in this case, I'm going to say categories bang 5, which is the one we were looking at before. Close this tag, close this element, and close this guy. So now I'm going to just take this, literally this text, and do an HTTP post to the /products container. So click there. So this returns 201. 201 in HTTP means created. And it gives me back the final payload in case something changed on the server side. Maybe you update something when you're creating or add some property or modify some based on some business rule. So we gave you the final version. So now if we go retrieve all of the products, let's do a get here. And we search for techhead demo. So there is this guy here, and we can see the ID. So let's retrieve this particular one. I'll copy the ID. I'm going to paste it here. So here's the product. Here's the name of the product, the price, and the category. And if I go /category here, I can see that it was bound to category number 5 for that particular product. And I did that just by using the links in the payload that I was sending to the server. Similarly, updates work the same way. You just send the payload, and then we will go replace the value. And if you want to, in this case, change the category, it would simply send the link for the new category, and we will go wire that up. So one more thing is, since the system is so link heavy, oftentimes you have something like this where you have a product and you have the category for that product. So if you're rendering something in the UI, very likely you want all of these pieces of information. And in order to prevent the application for having to go back and forth between the client and the server multiple times, we have also a construct to allow you to say, actually, don't give me just this resource. I'm going to give you the resource and a set of links that I want you to traverse and give me the whole graph. So the way we do that is, let me switch back to the big view here. No, that. So let's say we want the product and we want the category for that product. So what I can say here is, I can say, give me the product, not the category. But while you're at that, expand the category for me. So what this does is, you have the product, which is list price, color, photo, and all those things. And then in the link, in addition to getting the actual link that points to the category, you get the category itself right here. In JSON, it looks like a nested array. Like if we go do this, or a nested property rather. We do this here, and we switch to JSON. You can see that there is the product, and then when we go to the category, you can see that the category is here, and you can see the name of the category nested under the product. So the effect is, for example, in JSON, you can say product.category.name, and it's already there. So similarly, if you have, say, customers and sales orders, you can say, this is the link to a customer. And by the way, when you're retrieving the customers, also bring the sales orders and maybe the sales order lines for those orders and so on. So you can paint a whole graph. That is a nice sort of bandwidth optimization, so you can reduce the latency of the overall application. So switch back to this for a second. As a quick recap, so what we do is we take an EDM model, a schema, we paint, we turn them into resources with links, and then we use URIs to point to them. And then we exchange those things using HTTP. We send the URI, we get back an object, or we send the object with a URI, and we modify the thing on the server. And then you can negotiate which formats you want, and you can layer this on top of multiple data sources. So let me get back just for a second and talk about data sources. So all of this so far was on top of a database. And I'm just I have a SQL Server service running in the computer, and I'm just using that. You could also do this over non-database stuff. The way this works is actually fairly straightforward. What you can do is you can define any CLR type. Like, for example, here I have a trivial example where I define the type called person. And I'm saying person is something that has like an ID, and it has a name and an age. And then I define the class called contact data. What we do is we take the data source class, and we look at every iQueryable property. And iQueryable is basically an interface that allows you to express queries and compose queries on top of queries. So you have an iQueryable, you can add like a filter predicate, and that gives you another iQueryable, and then you can add a sort predicate, and that gives you another iQueryable. So it's a nice way of negotiating a query between a data source and the Astoria service. So basically, what you do is you return a base iQueryable. In this case, I'm just doing it in memory. Like I have an array of people, and I'm returning that as an iQueryable. Which is, I don't think this is a realistic thing, but sometimes you may have some in-memory data you want to expose. Most likely, though, what you may have here is access to some other service out there. This is where, if you had, say, link to Flickr or link to Amazon or something, this is where you would plug it in. And the nice thing is, once you plugged it in here, then the interface that you expose is consistent with the other Astoria interfaces, which means all of the technologies that support the Astoria runtime will work with your service automatically. And this is what I'm going to talk about next. So now we have a bunch of URLs and payloads and sort of a few bus names out there. So what do we do with them? So there is a number of scenarios that we want to tackle. And for each one of those scenarios, we have specific components that help put together an end-to-end story. So first scenario is the one on your, I have to think like 15 seconds to figure this out, on your left. It's around services and platforms in general. Like one of the things that is increasingly common is these services that become whole platforms. You can think of MySpace or Facebook or all of these sites that started being sort of just a website, and now they are whole development platforms for other people to go consume and create sort of value-add solutions and so on. In the commercial space, similar things happened with Salesforce.com and other companies that are sort of investing in that space. So how do you create these services? That's the first part. Is if you want to either create a sort of a service to be exposed to the web as a data service, or you want to use this as a building block to create your own very dynamic Ajax or Silverlight application, how do you create the server side of this thing? Let's drill into that. So what I have here, let's switch to another project. This project is, I have some things prepped to go through in a second, but I'm going to create a service from scratch. Like the actual process of creating a service is exactly what you would do if you want to go try this out. The only thing I did is I created a web application project. And now, first thing I'm going to do is I'm going to use a database. I'm actually going to use the same database I was using in the previous example. So I need an EDM model. I mean, the previous example, I already prepped it. But let's say we want to do the whole process. So I'm going to add an item to the project called the ADO.NET Entity Data Model. And we're going to call this thing bikes. I can create a new model from scratch. In this case, I have a database already, so I'm going to use that. I have to point the system to which database I want to use. In this case, it's my bikes database. And so this goes to the database, retrieves metadata from it. In this case, I have a bunch of tables. I'll just leave all of them there. And this goes and looks at the metadata and produces a default EDM mapping on top of the relational system. Then you can tweak the mapping. You can come here, open the resulting schema, and tweak the mapping to meet your needs. EDM is a very rich data model. It supports constructs such as inheritance, many-to-many associations. It supports abstract base types. So it's a fairly rich modeling infrastructure that then allows you to map this back to the database. And by the way, this is not Astoria specific. The entity framework and the entity data model can be used directly in the middle tier as well. And also, you can define the mappings to the database. In this case, I'm using the default mapping. Like, for example, this is the customer table, and you can see the one-to-one mapping between the columns in the database and the columns in my service. The important thing is what we're exposing to the web is this schema, not the database schema. So as you model this to better meet your needs, this is what is going to be exposed. Like, for example, here, I don't want this table that is right here called customer access. So I'm going to just delete it, and that is going to disappear from my service altogether. So I hit save. This generates the model and also CLR types that correspond to the various constructs in the model. Next step, once I have a model to get the data from, is to create the service itself. So for that, I'm going to go to the web application, another new item. And in this case, I'm going to choose ADO.NET Data Service. As part of productizing this whole Astoria thing, these names never survive. So looks like the name is ADO.NET Data Services. So we'll create one of those. I'm going to call this thing bikes as well. So this is a service. And what this creates is a special form of Windows Communication Foundation, or WCF service, that is aware of the data that is going to expose and presents this interface automatically. So now that I have a service and a model, I need to tie them up together. And the way I'll do that is I'll bring in my bikes model namespace that was generated when I saved my EDM model. And I'll tell the system that the source for my particular service, let me delete this comment, is the bikes entities EDM schema. So if I hit save here, this is what happens. And hit save and run, of course. That's not supposed to happen. Let's go bikes.svc. That. So I get nothing. So by default, this is just too tempting to do like 10 clicks and expose all of your database to the web for people to come and party on it. So we disabled it. So the way this works is you set up all the stuff, and then you have to tell us what you want to expose and how. You can do this at different granularity levels. There is one granularity that is whole containers. And then within the container, if you want, you can create your own custom policies that define what data is seen and when it is visible, like depending on which conditions. So I'm going to just, like, for the sake of this example, I'll just enable everything. In the next slide, we'll drill down on security and talk about how you do this without open your database for party on. So there is a special method called public static void initialize service that takes an iWeb data service configuration, config, and you can use this method. This method is called during service initialization, and you can use it to set various policies. In this case, I'm going to set the resource container access rule, and we have this demoware only .do it at home option where you say star, and which means show everything. And in this case, I'll say allow every container and allow every operation on it. Typically here, you will choose what you want, like you want to allow reads or writes or read to specific things or only deletes and so on. In this case, I'm going to say all. Again, don't do that. So if I run this again, and I go back here and refresh, so this time I'm going to get sort of the whole service with all of the metadata in it. And so typically in practice, you land somewhere in between, and we'll elaborate on that in a second. So now I have the same service I had before. So steps are fairly straightforward. Grab a data source, either a link implementation out there, or if you have a database, use the entity framework. Entity framework talks to many databases out there. I mean, of course, we have an emotional attachment to SQL Server, but if you do like Oracle or DB2 or whatever, go for it. And then once you have a data source, you model the shape of the data you want to expose, create a service, put the service on top, and that is already visible. Of course, then you have to go tune the security settings, and I'll get back to that in a minute. So first step, creating a service. Switch to the slides. So second step, right in the middle. So once you have a service, you may want to do a number of things with it. One of the use cases that we want to support is that when you have a service, you want to create an Ajax or a Silverlight application that is sort of a rich, interactive application on top of that service. In this scenario, it's not so much that you have a service exposed to the web, like in general. It's more like your own application needs to exchange data between the web server and the client, and you use Astoria to provide that service. So let's build a quick one of these applications. So I'm going to continue with the same project. We just created the service, so we are going to build on top. What I have here is I have almost a default web application, web page. And let's say that what we want to do is we want to list the categories, the product categories that start with a given prefix. So I have an input here that is called prefix, and a button that basically you click on the button. Let me switch to design view. You put a category prefix name here, like you're looking for some category. Then you click this thing, and you go find the category. So let's switch to design view again. So how do we do that? Let's say we're building an Ajax application. So it's all JavaScript. So one of the things we do is, in addition to give you server components, we are building client-side libraries and components that leverage the fact that we have a very uniform interface, regardless of which service you're talking to. So we can make assumptions about the URL format, about the payload formats, and so on. So let's say that every time you click go, we want to go retrieve the categories with the particular prefix. So first thing we need to do is we need to pull in our JavaScript library. So I'm going to use, by the way, I'm using the Atlas, well, it's not Atlas anymore, the Microsoft ASP.NET Ajax toolkit to do all of the sort of JavaScript work. So I have to type less right here. So I'm going to point to my library. I'm sure the final name is not going to be that, but it is that for now. And so whenever you click the go button, this method is called, and page load was a weird name, so I'm going to call it list categories. So now we have to implement the list category methods in JavaScript right here. So list categories. What do we need to do here? We need to point to the service and tell the service with a URL which category objects we want, which product category resources. So we're going to use a JavaScript class that comes with the Astoria client library called a service. So I'm going to say new sys.data.data service, and the argument is the URL to the service object or the service path. In this case, since I'm in a web page, this is relative to the page, so I only need to put the resource name. So now what we want to do is we want to send a request and get the results back. So this is fairly straightforward in the library. I can simply say query, And what do I want? I want slash category. And then I want to use the filter construct that we used before. And in this case, I'm going to use the starts with, there's a built-in function. And I'm going to say the name has to start with, and then here I need to put something, like whatever it comes from the field. So let's go find that. I'll say var prefix equals, I need to go get this guy, the value of the input. So the ID is prefix, so we're going to get that and put it here. And of that, I want the value, which is what the user typed. So then here, we're going to say plus value plus close the quotes and close the parentheses. So that is our URL, right? So next step is, how do I get the results? The A in AJAX stands for asynchronous. Like, you don't want to block the user interface waiting for the web server to respond, because these are very high latency environments. So you want to stay responsive. So instead of trying to wait for the result here, you provide a callback. This is very standard of sort of AJAX environments, and there's nothing specific about Astoria here. So when we are called back, I'm going to call a function called render categories. And then if things go wrong, I'm going to call a method call went wrong. And that's it for now. So this, you call this function, the function will kick off a request, and then the function returns to the user. So now the request is pending. When the response comes, two things can happen. Either the thing worked or it didn't. If it didn't, the went wrong method will be called. So let's implement that guy. And we'll have a simplistic implementation, like this one, for example. And now if it went well, it called the render categories method. And the argument that it will pass is the result. Now, in this case, what this library does is it sets the content type expected to JSON. So on that way, on the way back, we can just eval the results and give you objects. So there's no parsing to do or anything like that. The result is literally, in this case, an array of category objects, in JSON objects. So what do we want to do? Let's say we want to render them here, so I'll add a div. I'm going to call it table. Oops. That. And we want to put stuff in this table dynamically. So while we're waiting, we're going to put loading there. And then here, we will put together a little bit of HTML. So I'll go HTML equals new. I'm going to use the string builder, also part of the Microsoft AJAX toolkit. And then we want to iterate over each category. So I'll go for I equals 0, while I is less than result.length. Again, it's an array of categories, so I go over each one of them, increment I. And for each one of them, what we'll do is we'll append a little bit of HTML that says line item, and then put the name of the category. So I'll simply say result bracket I dot name. Similarly, I could say category ID or dot product and go fetch the product and so on. And then I need to close the line item tag. Close it. And close the loop. Finally, I need to close the list. So I'm going to say append here, close the list. And once I'm done, I need to go find the table div that I created before. I'm going to replace the inner HTML with HTML dot that to string. So again, like we enter a prefix, call the method kicks off the URL on the server, and on the way back, we render it on the screen. There are so many things that can go wrong here, so let's see what happens. First of all, we need to know the name of the categories, and of course, I don't know any. So let's go here and say bikes.svc/category. So there is a bunch of categories that start with bikes. So I'm going to say bikes. Click go. Go. Everybody knows but me. Come again? Like here? Here. That's perfect. Thank you very much.
Also, you've got results on leg cutter.
I have a what? Perfect. It's like very extreme programming, right? Let's see. OK, at least we have a loading thing going now. So click go, and we get bikes. whatever. Let's find something else that is not bikes. Components. So if we put components here, then we get components. So I mean, it's a simple thing right now, but the interesting thing about this is modular security policies. I didn't write anything on the server to build this. And if you look at the client code, especially if you don't make all of these mistakes, client code is actually pretty clean. Like, it has all UI information, but there is nothing there around how to deal with the service. We've taken care, for the most part, of that for you. The same library, just like it has query support, if you look at the service, we'll do IntelliSense here a little bit. There is an insert method, for example, that can create a new entry. There is an update method that updates an existing item. And also, if you want to do a bunch of operations together, there is a create action sequence method that gives you an action sequence object. And then you can pile up all of your actions and send them to the server in one go. So this makes it possible to do sort of an interesting end-to-end where you build a service on the server side, and then you build the interactive piece of the application in the client. Of course, this is not going to fly if you don't have business logic on the server to protect, again, people from doing some nonsense on your data, and I'll get back to that in a second. Let me get rid of this guy before I forget. So this is, so far we've been doing JavaScript. There is also Silverlight. Silverlight is like a fashionable thing to talk about these days. And I was going to prep a demo, but actually, so one of our MVPs, Sean, built a very interesting application, and it's out there on the web. So what I'm going to do is, instead of show you an application, I'm going to just run his application right from the browser in the demo machine, in the PowerPoint machine. So there's like nothing installed here. So I'll go to Silverlight data, which is his website. And what he did is he exposed a service over the Northwind database. It's an example database. And he built a Silverlight applet on top of it using our components and our APIs. So this is Silverlight. Like, this is the only way I can think of showing that it's Silverlight. And then you have the categories here. You pick a category. It goes to the server, brings the data for that category. You pick one of them, and you get product information and supplier information for that particular guy. And the interesting part is there is no data on the client, and there is no data coming from the thing itself, in the DLL. All of this is being exchanged dynamically between the client and the server. And who knows how many sort of firewalls and proxies and weird things are between this computer and his server, right? But it doesn't really matter because it's going through the same infrastructure that is being used to serve the web page. So I'm going to talk in a second about what the API for Silverlight looks like, but I thought it was fun to show random example out there is available on the web. You can actually go there now and you'll see the exact same thing I'm looking at here. So we went through how to build services. Then we went through how to consume services in Ajax applications. The last thing I wanted to touch on is, it's becoming increasingly common to have services. Big companies, Facebook is a service, MySpace is a service. All of these guys are whole platforms, right? Like Flickr. So if you want to roll one of those, what do you do? So of course you can create your own from scratch, but it's a bunch of work to build it and then to maintain it. And also, once you're done building it, you need to build all of the client tools. You need to build integration to the development environments. You need to build libraries. You need to build controls. It's an expensive thing to do. So we're trying to help in that space by enabling the scenario where what you do is you expose a service and then you can consume that service. Let me show you a quick example of how to consume an existing service. In this case, I'm going to use a console application, but the code I'm going to write is the exact same code you can write inside Silverlight, or inside a full-on .NET application, or maybe a WPF application with these fancy UI effects. I'm in the database team, so I'm like 3 tiers down from a fancy user interface. So I'm going to stick with the console application. So what I have here is an empty console app. I only set up the references. And so what I want to do is I want to go talk to that service. So first of all, we want to do this in terms of .NET objects, because it's already in the development environment. It's very easy to use. You get IntelliSense and all that. So the way we do it is you can create your own types. And as long as they match structurally with what it comes on the wire, we'll just create instances of your types. If you don't like to create your types or you don't want to spend the time doing that, we have a little tool that it's going to be integrated into VS, but right now it's a command line tool, and it has like the worst set of arguments ever. So I have a batch file because I never get them right. So there is this web something demos client, and I can just open it real quick just so you can see what it looks like. It's not that interesting. So there is a utility called web data gen, and what you pass two arguments, two important ones at least. The output file that you want, and probably the most important one is the URI to the service you want to get the data from, the metadata rather from. So you point to that service, we go retrieve the metadata for that service and create a bunch of .NET objects for you. Let's run this thing. And I'm running it against the service that I already sort of kicked off before. So among other things, the service has to be running there. So now here, I can go and add to my project the bikes.cs file. And this is yet another automatically generated code file. Nothing special to see here other than each one of the elements here mapped to the elements of the resources exposed by my service. So now I'm going to use an add bikes here. Let's say I want to consume this thing. Again, this client is across the web from my server. I can make no assumptions whatsoever of how I talk to the thing other than just plain HTTP. But I want to do it in a way that is natural for my .NET environment. So first thing we do is we create an Uber object that represents the service as a whole. So this is bikes entities in this case. We call this a context for a session, for a service context. I'm going to call this new service. And now let's say I want to retrieve customers. So what I can do is I can say enumerable of customer, and the type is there because it was generated by the tool. Say query. Actually, let's do products so I can filter on something. Query equals context dot create query, and I can say of which type. If this was a custom type, you just pass it here. In this case, I'm going to pass one of the generated types. And what is the URL that I want? I want /product. And then let's say we want the red ones only, so filter color equals red. And so one thing I missed here is you need to tell us like who to talk to, what is the service. So here I'm going to say HTTP, and I fixed my server at localhost 50,000 there, /bikes.svc, which is the entry point to the service itself. So now that I have this, what I can do is I can just go and for each over the query object, and that will cause the thing to execute on the server and come back. So I can say for each product p in queue, console, for example, dot write line, p dot name, as in the name of the product. So if I hit F5, get some random error. Oh, this is kind of like everybody close the eyes. No, right? So this is a feature. No. So this is a glitch in the code gen thingy, and of course, we fixed it, but I didn't want to put my computer upside down the day before. So, so here is the list of products, in this particular case, products of whatever color, I think it was red, and including the one we inserted a minute ago that happened to be red as well. And so look at the code. It's like, you're talking to the thing. Like there's no HTTP GUI in it. Like there's no serialization. There is no sort of request response thing. It's entirely expressed in terms of the environment that you're working in, but still, this will use just plain HTTP to talk to the system. In cases where you don't want to block the UI, because this has the same problem as the other one, the web is sitting in between, we also have an option to, let me go make this the right type. We have an option to say begin execute, which does an asynchronous execution. When you say begin, we kick off the thing, and then we call you back when we're done, and then you resume your work from there. So like in Silverlight, for example, you can use that to not block the UI. Finally, this is all good, but so like these days, it's very fashionable to use LINQ to formulate the queries themselves. So what I want to do now is take this query that I have now, or some query, and instead of writing URLs, I want to do LINQ to interact with my server over HTTP. Yes? So the question is, the bikes entity class, what does it derive from? Let me just do this. This is the definition. So bikes entities inherits from web data context, which is a base class provided by the client library. And if you use the tool, you always use the typed version. But if you want, you can just use web data context and define your own types and never use our code gen mechanism and never use the custom types. They're handy to use, but sometimes maybe you're writing a generic tool or something and you don't know the types. So we have a way of using generic types instead of fixed types, and you can use the web data context to access them. So let me turn this into a link query. I'm going to change the query a little bit. Let's make it a little bit more complicated. Let's say we want the particular products from a specific category. So we have to do like a traversal operation. So I'm going to say from C in context dot, and we generate all of the entry points for you. So everything is typed at this point. Now I want a particular category. So I'm going to say where C dot category ID equals 5. That's the category we used to insert the product before. And now I actually want the products, not the categories. So I'm going to say from P in C dot product, because we know that there is a relationship between categories and product, and we generated the type, so it represents that relationship. So you can write this query here. And then I'm going to say select P. And just to throw everything together, let's say I'm paging over these things, so I'm going to wrap this in parentheses and say, by the way, skip the first 5 and take the next 3. So this should yield 3 products from the category number 5. The nice thing about this is you're not going to be able to tell if it's the right thing or not. It's just 3 random products. But you can go check the database afterwards. I promise are the right ones. So again, this query is even more disconnected from the web environment. I mean, of course, there are restrictions on the class of queries you can write there, because we have to be able to turn them into URLs. And so what we do is we are very careful and we fail very fast. So whenever you're writing something that we cannot represent, we don't try to be very smart about it. We just say, look, like that query is not translatable. Either pull more data and write it on the client, or create an operation in the server, which is the next topic I'm going to talk about. Just a nice little feature. If you debug the thing, once I get over that line, if you hover over the line, you actually can see the URL that we generated for that guy, which are the same URLs I was using before. It's just that this one was translated off of a link query. OK. Switch to the deck for a second. So that was a client. Client runs on Windows, on .NET in general, runs on Silverlight. Silverlight itself is cross-platform, which means this client runs across many platforms. You can use it. I could do the same demo in Mac, and it would work. Also, in addition to the client, we're building a data source control for ASP.NET. So if you have a web application on the server that consumes a service from somewhere else, you can use the data source control. Just give us the URL, and we'll go pull the data from the service, and you can just bind it to the URL elements, and we will do all of the wiring up under the covers for you. OK, so these are the basic components and how they tie up to scenarios. Now, I want to elaborate on a particular area. So once you have all of these sort of end-to-end together, an interesting question is, fine, now you have your data out there on the web. What are you going to do so people don't skip over my business rules? How do you control what is visible or not, and so on? Let me spend a few minutes talking about that. We have a number of mechanisms that are used both for access control and more in general for business logic. The first one is the one I mentioned before that controls visibility of whole resource containers. The second one is something we call service operations, and allows you to package a whole operation in a URL. Basically, you can take over a piece of the URL space and attach your own function to it. The next one is probably the most interesting from the access control perspective. And what it lets you do is you can say, look, whenever, let's take products, for example. You can say, whenever somebody's saying querying for products, meaning any URL that lands on products. It could be /products, or maybe /customers, /sales orders, sales order line, product. Like, it doesn't really matter how you land there. You can say, whenever you land on, say, a product, apply this or compose the query you're going to use with this query, and you provide the query, this link. The nice thing about that is this is a declarative way of saying how to compose the queries that we generate with the queries that you want. But then once the query is composed, we ship it to the data source, the database or whatever is the underlying source, so that we don't have to pull extra information or anything to enforce these policies. These policies are pushed down to the source of data and enforced there. So there is a performance aspect to it, and there is a security aspect for it that is interesting. And then finally, I mean, that's nice for querying. But on the way back to the server, when you're sending entities for updates or for creation, you want to typically run validation rules, and also you want to apply security there. Can you modify that property? Can you add a customer of that kind? And for all of those, we have a mechanism called interceptors that does precisely that. Like, it lets you run code. This is much better shown by example, so let me just switch back and show a couple of these. So this is back to the service we were building before. So let's quickly go through a couple of them. First one is the service operations concept. So the access rules are here. Like, basically, you can say, I want to be able to see customers and sales orders, but not products. And we'll show you only that and get rid of everything else. So there's no way you can get into products, for example, if you don't list it here. So if you want to do a service operation, what you do is you decorate your method with webget, and then you create a method. And the trick is the method returns a queryable, so that we can, whatever is the output of the method, we can still compose it and plug it into our query composition pipeline. Let's say we are going to return customers, and then this particular URL is good customers. And let's say a good customer is a customer that has a minimum amount of sales that is an argument. So what I'm going to do here is write a link query. Of course, here you could write business logic that does whatever you want, extract credentials from the context, go check some other data source, or at this point is your code running. So in this case, I'm going to return a query that says so I want to aggregate the sales order lines for a particular customer and check if the sum of the value of those orders is more than the minimum sales that is here. So this is kind of an unusual query for link, but after a while, you get used to these things. I'm going to say for line in, and which database you talk to or which data source, we actually inject that as a dependency into the context. So you can say dot current data source, and this means like the right thing. This is the thing that the data source this service is running against. In this case, this is sales order line, and I'm going to say group L by L.SalesOrder.customer. And I know all of these relationships because they are expressed in the schema. I'm going to call it G for group. Now, what do we want? We want those that have a minimum of million sales. So I'm going to say where G, which represents a set of lines for a particular customer, that sum line, and then what is it? Well, the total is the sum of the unit price times the quantity. So I'm going to say line.unit price times line.quantity. And then what I want is the customer itself, which is the key of the grouping. So finally, actions are also, or service operations are also hidden by default. So I'm going to enable this right here. I'm going to say allow any action to be visible. So if I run this guy now, perfect. Thank you very much. And go back to the service, of course. Bikes.svc. Now I can say / good customers and mean sales of something. And this will yield all of the customers that have this minimum amount of sales. The nice thing is we just can compose that query. So if then on top of this you can say order by or top or something, it will still work. Like, for example, if I say top 2, this will yield top 2 customers that do all that. Because we take the iQueryable and keep composing queries on top. So this does not prevent the query model from working, which means all of the client tools that automatically understand this will still work. So the final thing is, what if I want access control over this thing? So let's say I want this scheme. I know it's kind of weak. Of course, you can do more interesting ones. If you are not authenticated, I'm going to show you only red products, whatever. And if you are authenticated, I'm going to show all of the products. How do we do that? So we can say public iQueryable of product. And this is, I'm going to call this on query products. And the input is also an iQueryable of products queue. And I'm going to tell the system that this is the interceptor method for querying products. So I'm going to literally say query interceptor of product. So now here, what I get to do is the queue that is the input is what we produced as a default query. So I'm going to add using system.web so I can check for web stuff. And here I'm going to say if http context.current.request.is authenticated. So if the thing is authenticated, I'm going to return the input query. So whatever you want to generate, we will go run that. We trust the guy that is on the other end. If you don't trust the guy on the other end, I'm going to return another query that says from P in Q. So I'm composing on top of the other query. I don't even know what the query looks like. Where P dot color is red, select P. And that's my return value. So of course, this is a silly scheme, but in a more interesting scenario, you could imagine, for example, you have your products table and an access control table. So based on the user ID that is authenticated, you can join the products and the access control table, and so the rows that are not in the ACL table will get dropped. So you have row level security right there. And you can make many other security policies built on top of this base system. We can run this. This is not going to be very exciting. It's like red products or all the products. Let's do it real quick here. And I'm going to say /product. So the way we can see if there are red ones, I'm going to say filter on silver. And I cannot see any product. And the reason is because I'm not authenticated. So if I go to web.config and switch the authentication mode to Windows, which is nice because I don't have to do anything to authenticate, and then hit refresh here, this time the browser will do automatic will log in on the server, and now I get the products. So I get a very fancy security mechanism that can be applied to any particular policy for security that your organization happens to have at no performance cost in the middle tier. I mean, these things get pushed down to the database. Of course, somebody does the work to filter them, but it's probably the best place where you can do the work. OK, so to close on this. So what is the point of all this? So the point of all this is that you can imagine a world where the way data is exchanged is there is a bunch of tools from Microsoft or third parties, and there is a bunch of services. Your own services created using Astoria servers, the consumer services in live.com, or even infrastructure services out there on live.com. And the thing is, the way services are produced and the way services are consumed out there is uniform across the board. You use the same tools, same runtimes, same concepts, and so on. So there is a nice opportunity here sort of in the making, and this is the first step in this direction. So we're very excited about this for this precise reason. So quick roadmap. This thing officially is called the AD.NET Data Services, and it's a framework. And we did a couple of CTPs already. It's out there. Once Orcas or Visual Studio 2008 ships, we will refresh our bits, and we'll ship the first version that is a production class runtime. We rewrote it since last CTPs. The CTP was a prototype. Now we have the real thing. So we will do a first CTP of that very soon, like probably next month. And we're thinking that we'll ship a beta early next year and RTM it, I don't know, mid next year or so, first half of next year. So that's more or less what the picture is looking like. So so I still have a couple of minutes for questions, but we are far away. So first of all, let me thank you very much for coming today, and I'll take a few questions here. Thank you. Yes, question.
How do you generate views at do you use the syndication process?
So the question is how we generate the Atom, the payload. Today, we're not using the syndication classes just because of timing. They were working on it. We were working on this. But we are actually considering moving to their syndication classes. Yes? The question is, for the library that composes operations, is there a way of putting that in a transaction? So when we compose the queries, we do single line queries or single statement queries only. So those are always implicitly transacted. In the case where you have a service operation, where it's your code and you can have multiple steps, we are fully integrated with system transactions. So you can create a transaction scope around your activity, and you'll be running inside the transaction. The only thing you need to be careful is, you need to do everything inside the transaction. If you give us a query that is then outside, we may deadlock with ourselves because you give us a query that is for deferred execution, and if then you pull the transaction, if you don't pull the transaction, you don't commit it, then we may run into your own logs. So you need to be careful with that. Other than that, regular system transaction stuff, nothing new. Yes? Great question. So what about exceptions? I actually forgot. I was supposed to talk about that. So we do a couple of things. First of all, we very carefully follow the HTTP error codes whenever we can, both positive and negative cases. And then you can throw a regular exception, like any random exception. And in that case, we just say 500. Something weird happened. But we're also introducing a web data service exception type that you can pass an HTTP status code and a message. And in that case, we honor your status code. So you can be very specific. And for example, let's say you have an update interceptor, and because of some custom rule that we don't understand, you want to reject that request, you could say, throw a web data service exceptions of 403, which means forbidden. No, it's not an exception in the .NET sense. It becomes a standard HTTP error. So you get the status code and the text. Yes? So the question is, what metadata format is used in the service? So all of the system is EDM based. So EDM has a metadata form called CSDL for Conceptual Schema Description Language. We use that. That is nice because it's supported by the tools. And also we include an XSD schema with Visual Studio. So you get IntelliSense editing. You can do your own validation if you want, and so on. Yes? Yeah, it's on now.
Okay, wondering where you place this technology in the Microsoft architecture for getting data. So we have Link, we have WCF,
yes.
We have web services, we have binary stuff.
So
is it? I've seen Link being used now. So
I think there are sort of two dimensions to this. There is one that is the data access technology, and there is another which is the multi-tier technology. In the data access technology, basically what this stack looks like is, if you're going to a non-database, then there is no prior art there, so we just use Link. If you're going to a database thing, then the common path is through the entity framework, which in turn builds on top of AD.NET, which is sort of existing stuff. So I think in that space, this is not new. This is not an alternate option. This is a next tier. Like AD.NET and Link and so on help you talk to a database that you have line of sight with. Like you have to be able to connect to the system. So this technology helps you doing the same data access work on the next tier between the web server and the consumers of that service. Okay, let me get to that one. So then the other aspect is, so that one is sort of the query aspect. And Link is great because it sort of has very broad availability out there, even though it's so new. So we're leveraging that. On the communication aspect, so WCF, basically, there is a spectrum of how structured you want your contracts. For the case where you want a traditional SOA style, very strict contract, WCF in the traditional sense is the choice sort of hands down. In that case, it's more of a procedural model. You make a function call, you pass a bunch of arguments, and you get a structured response back. And that's great when you want multiple components that are very highly predictable, composable, and you own most of the end-to-end. The other end of the spectrum is these flexible data services that Astoria exposes, where you don't want, you want to be able to move fast, and you don't want to say, whenever I want to add a new sort column, or whenever I want to be able to insert in a different way, I need to go create another operation contract in WCF terms. So this is also an WCF technology, like it's built on the same infrastructure, but it addresses a different set of scenarios that we were not addressing with WCF alone. I think so. I think it's up for debate. I personally think there are some scenarios in the enterprise, but I have talked to a number of customers that prefer the more structured, more SOA strict style. I actually think that it depends a lot on the nature of the problem you're trying to solve. For sort of OLTP style, very heavily structured things, I don't think it applies. For organizations that want to share data broadly, and they want to leave people to do rich interaction with that data, I do think it works. And so my favorite example is I'm almost out of here. I'm getting the look, so this is the last one, and then we can talk outside. My favorite example is, in Microsoft, we have this product, this bug tracking product. Not like we have a lot of bugs, but for the occasional bug here or there. So the client is like a Windows application, and it talks to some middle tier thing, and the middle tier thing talks to the database. Now, I actually work on the SQL Server team. If you ask me how to get to the database, I don't know. It's managed by IT, 15 layers of teams separated from me. But I don't want an RPC interface to that thing. I want a rich Like I want to build my reports, and I want to build my clients, and I want to create things, and so on. So I think that for that class of scenarios, a data-centric interface, I think, is better than an operation-centric interface. So it boils down to, it depends on which problem you're trying to solve. Is that a fair take? Okay, so I'll be outside. Why don't we talk there so we leave up the room for the next people?